Okay, our first lesson of term 3. So we're starting with our functions and we're doing a nice and easy one first, which is our parabola. Okay, now, what do we remember from grade 10? We know that our standard form is y equals ax squared plus bx plus c, or we used many times q, but that doesn't matter. Okay, so this y can also be equal to fx or gx or whatever they name that graph. Okay, but we always know it's y. Okay, then if a is bigger than 0, we know we have a smiley face, which is a positive parabola. And if a is smaller than 0, we have a frowny face, which is a negative parabola. Okay. If we want the y-intercept, we make x equal to 0. And if we want the x-intercept, we make y equal to 0. Now, this statement is a general rule that applies to most of our functions. And I do want you to make a note of it specifically and remember it. So we did do this previously, but it's a good reminder. Okay, in grade 10, the turning point was always on the y-axis, and we called it q. Okay, but now, in grade 11, our parabola can shift left or right, which means our turning point of a parabola won't always be on the y-intercept, which is q, okay, or in this case, c. Now, earlier when we did our quadratic formulas, I mentioned this briefly. I don't know if you guys remember, but this is where it is coming to go into effect. So yeah, keep that in your mind. Okay, so to help this, we have new formula forms, which is just our standard formula manipulated. Okay, so if we briefly go through them, and again, like guys, we're going to do examples of it. We're going to work through this. This is just a few things I need you to remember beforehand. I need you to make notes and yeah, so that when we get into our examples, when I talk about something, you already know what I'm referring to. Okay, so our standard form is y equals ax squared plus bx plus c, and when we get it in this form, whatever is in front of the x squared, we take as a, whatever in front of the x is b, and our constant term is c. Okay, now how to get my turning point? First, always I want my x coordinate, and I'm going to take b and a, which I find over here. Okay, please remember, if b or a is negative, to substitute it with your negative sign in brackets, because here in our formula we have a negative b. And if this one's negative, it's a negative times a negative, and that will change my whole formula. The same with a if a is a negative. So please remember that. Okay. Then as soon as we have our answer here, we substitute it back into x and we solve y. Okay, then I would have my x and my y coordinates of my turning point. Now, if I have it in turning point form, which looks like this, again, many times now you'll get your formula in this way. They'll ask your parabola in this way, just because, yeah, it's a bit easier. But sometimes they can ask you to, how can I say, manipulate your standard form into your turning point. So write this one in turning point form, they might ask, and we'll go through that in our examples. Okay, so when we get it in this way, how to get my turning point, I'm just going to use p and q and substitute it into my coordinates, and that's that. So no maths involved here, you just need to know where to find it. Then my x-intercept known. So if I get it in this formula way, I know that my x1 is my first x-intercept and my x2 is my second x-intercept. Now this x that we find here is just our normal x that we find everywhere. Okay, so please don't get confused. I know it's a lot of x's in one formula, but bear with me. Okay, so now when my two x coordinates are known, I can add them together and divide them by 2. So for that, I have a simple answer as to y. Okay, so when I have this, if I do a rough parabola over here, we know that it is symmetrical, and I'll talk about our axis of symmetry in a little while. So with that being said, I have my one x-intercept and I have my second x-intercept. When I add these two together and divide it by 2, I get exactly where my middle is. Now, I know because of my Cartesian plane that my x value here would be exactly the same as my x value here. And if I have my x value, I can solve y. So this is just to find exactly the middle of these 2 points. So wherever I am on my Cartesian plane, let's say there, and I have my parabola turning at this point, I can still take this x-coordinate, divide it by 2, find my middle, and bring it down. Okay. And then find my y-coordinates of the turning point. Okay. So this one is my first x-coordinate plus my second x-coordinate divided by 2. As soon as I get my answer here, I substitute it back in. So my x answer here, I'd substitute back into this x. And my x-intercepts stay exactly the same. I just substitute in here. Then I solve for y. And then I have my x and my y coordinate. Okay. Now I briefly talked about this one, about a fourth method that's not on here. So I'm going to take the same principle as this, but to get this x1 and the x2 for my standard form, I'm going to use my quadratic formula and solve x. And as soon as I use my quadratic formula, the one that's on the formula sheet, and we worked with it earlier this year when we did our quadratic formulas, we can use it in here as well. Find 2x values and substitute that back. I'm lying. We're going to find our 2x values, add them together, divided by 2, the same as we did here. The value we get here, we're going to substitute it back into our original formula, and we're going to solve y. Okay, so it's basically the same one as this. We just have an extra step in it. Okay. Now, with that being said, and please guys, pause this, make notes. It is very, very important. Okay. Then our axis of symmetry. Briefly talked about it. Now, we know that a parabola is symmetrical around the y-axis. Okay. That means that if I fold a parabola vertically in half, it would fit perfectly. Sometimes I like to ask the equation of the axis of symmetry. We will look at that now. Where's my paper I used? Okay, so that is the same as the example I just used. When I add these two together and find the middle, add these two together and divide by 2, I find the middle because it's symmetrical. And even if I shifted left or if I shifted right, the parabola would still be symmetrical, which means I can draw a straight line down the middle of the parabola, and this half would fit perfectly on that half. We call that our axis of symmetry. Okay. So now they can ask you, what's the equation of the axis of symmetry? Now, when the equation of the axis of symmetry, oh no, I'm giving you the answer first. Ha. Okay, when we have this example, okay, we have our coordinates of our axis of symmetry as -1, -2. Okay, now here we're going to mostly look at our x coordinate. We say it's -1, and because this is a straight line down, we can say our equation of our axis of symmetry is x equals to -1. This is also the x coordinate of the turning point, and it's as easy as that. This is easy marks you can get, and they love to ask this question. It is a level 1 question because you can just read it. Now, when they give you, how can I say, the only way they can make this difficult is when they give it to you. Let me get my paper again. Let's say when they give it to you in a standard form and ask you the axis of symmetry, you first have to find your turning point and then you can give it. That's the only way it can become difficult. Okay, so this is a lot of information, and please, I want to see notes that you made. And yeah, any questions, please send me a message. We're going to do more examples on this, but first, make notes, memorize. Any questions, ask me on the group. Well, Google Classroom, or email me. Perfect. And yeah, that's that.